My name is Brij Raj Singh. You can call me Brij. I'm a senior software engineer with the commercial software engineering department. That's a new department in Microsoft actually. We just started operations in this July. Here's my Twitter handle and my email ID. Quick to respond on Twitter, of course. So today we are going to talk about Azure Blockchain, but before we get there, this is the agenda. We'll talk about what is a blockchain, what are the potential benefits of blockchain. We'll talk about some business scenarios just so that you get a heads up on what could be done with the blockchain apart from just the Bitcoin. And we'll probably do a small demo on Ethereum. I'll show you a very basic smart contract, and the next talk is anyways about contracts, so we'll take it further from there. The Microsoft mission is empower every person and every organization on the planet to achieve more, and this is one of the moves. Having blockchain on Azure is one of the moves towards that direction itself. The world is changing. There has been business disruptions like Uber, Stripe, Rent the Runway, Tesla, Airbnb, Oscar, Netflix, Bitcoin itself, the Climate Corporation, Metroline, etc., etc. And each one of the disruption itself has become a business model in itself, right? Now when you see a new business, you start comparing them with these disruptions, right? You see a Flipkart and you will say it's the new, it's like Amazon, right? You see a service and you can say it's like Uber, right? The second is that there has been a lot of technology disruption as well. There's been a lot of technology disruption in the big data field, in the cloud field, wearables and IoT, blockchain, privacy, robotics or smart machines for that matter. And there's been a lot of generational disruption. A lot of generations are there. I'm part of millennial generation, and then there is Gen Z or Zen Alpha, which is the new generation. And we are going to talk today more about the technology disruption. Our business transformation strategy is, there are 3-4 pillars over here: to reinvent productivity and business processes, to build the intelligent cloud platform, and create more personal computing. And by 2020, it's going to be more about Internet of Value because of technologies like Bitcoin and blockchain. So what is a blockchain? It's originally developed for international payments, that is the remittance from one place to another. And a blockchain itself is a secure, digitally distributed ledger that uses public or private signatures technology to validate and record transactions in near real time. How many of you are still confused about what a blockchain is? Be candid about it. Just raise your hand. Okay. How many of you are confused about the fact that there is another currency out there that is not backed by any government, so to say? Are you? We have been talking a lot about mining this morning, right? And the value is increasing, right? Can you buy something from that, right? Are people buying something from Bitcoins or Ethereum coins or whatever it is, right? Isn't that a confusion in your minds? There is, right? And the security behind it. Is it secure to buy? Is it secure to sell? Or is it secure to keep, right? Who do I go to when a mess up happens? These are all the questions that you have. Why is the mining getting slow? That's another question, right? Okay. So last night I was talking to one of my friends who was supposed to deliver this session, but could not. He's not feeling well, so I came. And we sort of draw an analogy last night in our discussions, and that analogy is very fascinating and interesting. So what I'm going to do is I'm going to cut short a lot of slides over here and talk more about that analogy, and maybe you will start comparing it with the physical world. Okay. So we'll start with the first days of ancient periods. How would people buy and sell? Was there a concept of buy and sell? There was a concept of barter system. Okay, I'll give you my cow and I'll take some grains from you. Okay, so the value of one cow is probably 2 or 3 sacks of grain, right? Okay, so now that this has been established, okay, if somebody else wants to sell his cow, he will say that guy sold his cow and got 3 sacks of grain, so I'm selling you my cow, give me 3 sacks of grain. Okay, now the grain production is slowing down. Okay, there are enough cows out there, let's say. Okay, in that case the guy who hoards the grains will say, hey, this is, this cannot be produced so easily, so I'll give you 2 sacks against 1 cow, right? So you can see how the valuation and devaluation of certain things happen, probably because they are so easily available or not so easily available. The times changed and people moved on to creating value out of the system. So previously there were things which are available, naturally available, right? Or you can probably grow them at will. So you can grow as much of grain as you want. If you hold the land, and earlier the land was really probably the cheapest thing out there. So if you hold the land, you can grow whatever you want to. But then the metals are out, right? Metals you have to go and find and mine and process and make, right? The easiest one to find was probably iron out there, right? So they found iron and they started mining iron, and then they said, okay, I'll give you this glass which would probably not break for next 100 years against your clay glasses. So this one has more value than anything else. Okay, now if you take this glass, I'll take this thing from you. Okay, then they found out that maybe this thing corrodes. Okay, it doesn't work as good. So they found more metals which were not easily corroded, like aluminium, like silver, and like gold. Now gold was lustrous and was not easy to find, and just because of it was lustrous is what drew people to it. Okay, if you see, it's just a metal, right? But the thing is that it's hard to find. It's lustrous. Okay, that is what makes it valuable for human beings. Okay, maybe for some other species on some other planet out there, it's a normal thing to have gold around, but for us it's very valuable. And as the time progresses, it's becoming difficult to gain hold on gold, right? Is it not? We've been mining gold since centuries now, right? It's becoming harder and harder to find. So if you go and do a small research around how much depth do you actually have to go to find gold, it's increasing, okay? And it's day by day increasing. The more it increases, the costlier the gold will become to you, because it's not easily found now. Which is pretty much the case if you draw an analogy to the Bitcoin. There are a fixed number of Bitcoins that can be mined ever on earth, and the more are mined, the harder it is becoming to mine more. Okay, this is the analogy that I think you will probably appreciate that we have drawn to.
There is one fact, Mr. Raj,
yeah.
We simultaneously agreed that we will give value.
Yeah.
But whereas Bitcoin, we still are not agreeing to give value.
We'll agree to it. Okay. Now I'm coming to another point, and I think probably I missed that point. Value to something is something which is in the heads of human beings, right? There was a time when in France the king will feast in an aluminium plate, okay, and aluminium plate was considered more costly than anything else, okay, because aluminium was recently mined, and the gold plates were not as much valued that time, but the aluminium was. So it's all about the time, right? Now about the currencies in the real world and how it happened, we'll talk about that. So since people started using gold, and say that if I hold this much of gold and I give it to you, of the grain and everything else, and then there are 10 different things like that, okay, and it's still happening right now. In the gold as well, if you take gold coin from one place to another and say, here, go take it. Earlier days, if you remember, there used to be these things called usher fee, right? Gold coins. And gold coins have some kind of emblem or marking on top of it. Why is there that marking?
Signify the region.
In earlier days, Yeah, so earlier days, if you take a small coin which is not marked at all, and you take it to any of the place in world, and you try to sell it, and you try to say, give me something against it, whoever the seller is would say, I would not accept it. It doesn't have the marking of a king. Okay, that king was probably the regulatory authority during that time. Later, the banks started appearing. Banks were financial institution backed by the support of the government, registered through the government, and they were there to sit and hold your money for you. Okay, they started holding your money. Earlier there were some lalas probably doing the same thing. You must have heard of the term hundis. Have you heard this term, hundi? Still exists, right? In hundi, a lala can make a hundi of, let's say, 10 lakh for you, and you can get it encashed anywhere in India. Okay, you go to any lala and you give him the hundi, and it has the marking of that lala, and it will give you, that much of money. So it's a small banking system that they have between themselves, which is pretty much like a draft, basically. So coming back to the discussion of having, so banks were there. Okay, so banks were holding your money. They were charging you to hold your money. They were charging you to move your money from one place to another, even if it cost them nothing. Okay, now think about this. You have 50 rupees that you want to give to your friend. Okay, and you did a digital transaction through the bank's website. You gave 50 rupees to somebody. Bank says, I need X% of this transaction. Okay, you very well can understand, maybe you have servers and everything, and you need to pay for them, and that is not enough that I'm keeping my money with you and you're using my money to buy or sell anything in the world out there. But yes, okay, fine, I understand, I'll give you X%. Okay, so let's say that doing a transaction takes them about, how much of compute power could it take anyways, but let's say it's a very frivolous amount. Let's say it's 2 paisa. Now you would have moved 10 lakh, and this guy is still charging X% out of it. He's robbing you, in a way, right? In a way, the bank is robbing you day in, day out. Okay, they take your money, and then they put restriction on top of it. Okay, another restriction you can see is that you have 2 crore rupees in the bank. You want to buy a Porsche car. You went to the person who sells you the Porsche car and says, I want cash. So you went to the bank and you said, give me 70 lakh rupees in cash, and the bank says, sorry, I cannot give it to you. I just can't give it to you right now. Take the draft if you will. No, I want the cash. So if I give you the cash and another party comes and asks for 70 lakh, I don't have that much of cash. I'll get the cash from somewhere else. When you were submitting, you were not saying that I'm writing 10 lakh and I'm giving you 5 lakh today, I'll give you 5 lakh tomorrow. This guy will say, no, you say 10 lakh, you give me 10 lakh today, right? So these kind of standards and these kind of practices put many people, in situations where they're thinking a lot and they're saying, no, the banks are robbing us. Maybe it would take nothing to have, a system wherein we don't need third parties, and that's when a person named Satoshi Nakamoto, he came up with a paper. He wrote a paper basically, and in that paper he wrote an algorithm and talked about an algorithm wherein there could be a ledger running on everybody's machine. Okay, and that ledger is a perfect copy of each other. Okay, this is encrypted as well. Okay, and it cannot be altered at all. Just like a bank's ledger, a bank ledger cannot be altered at all, right? If you send like 10 lakh rupees in a bank, you see a transaction ID. That's it. Nobody can do anything with that transaction ID. If you want to do anything with that transaction ID, you have to make another transaction and do something with that money. But that transaction is immutable. Okay. So he thought of the similar idea, came up with an algorithm, and it contains a lot of signature stuff as well. So you have a private key, and then there is a public key out there. So you sign every transaction with your key. Okay. Then he also created a concept of Bitcoin. Now Bitcoin, what it does is that he said, okay, the gold can be mined. Similarly, the Bitcoin can be mined as well. Okay. So anybody can participate and mine the Bitcoins. Okay. You mine the Bitcoins and you own the Bitcoins. Okay. If you mine, you own it. And he thought that it's pretty much like the gold rush, right? Right now, what we are talking about having these miners in our room is that they are part of that gold rush. If you go to history, you will find that there is a concept of gold rush. Okay, there was gold rush at a time in America, wherein everybody was trying to find locations where they can find gold. In those days, you can go to a river stream, can actually put a small filter over there, maybe a cloth filter, okay, filter the water and you will have gold in your hands. Okay, that was the time of gold rush. Now if you go to the same streams, you won't find it. Earlier it was coming, now it's not coming. Okay, in Australia you can go, there are places where you can go and dig for 2 feet and get the gold. Okay, but this is not the case anymore. It's becoming difficult and difficult. The analogy is just directly equivalent to what you have in the Bitcoin and the blockchain world. Okay, I hope it clears a lot of air for the people who do not understand any bit about Bitcoin and blockchain. Does it?
Yeah.
Okay, thank you. Obviously, it's not going to be exactly similar, but I hope it helps a lot of you. Okay. So in blockchain, the advantage is that the transactions are secure. Each transaction in the database is digitally signed and mathematically guaranteed to be authentic and impervious to fraud. Okay, that is that math problem we were talking about. Okay, all of you have to solve to verify that transaction. Okay, and when all of you solve, the same number comes, that means it's good. Okay, it's verified. But it takes time to do that. Okay, unlike a normal banking transaction which can actually take 0.001 second to happen, this one takes longer. Okay, so it's there, that delay is there purely because you want to go to other parties for verification. There is no third party involved. In normal world, it's a bank basically. The database main value is that it is shared between separate entities. It's shared between obviously different machines which are participating in the blockchain, and it's distributed. Many copies of the database exist and they are exact replicas of each other in relative time. And it's a ledger, it's a write once, thus immutable ledger that records every transaction. Now I see a lot of you are application developers in the room, right? Or have done application development. If I make a row in the database, then who stops me from altering that row? Nobody does that, right? I can go and alter it for my sake. Okay. Now banks don't do that because they are the trusted third party, but essentially they cannot guarantee you technically that it will not happen. Okay. It can happen if they want to. It can happen if the database gets hacked. It can always happen. But if it's a ledger which is distributed, which is secure enough, you cannot just crack it. Even if you crack it, then the transaction would not be verified by a number of people, and hence you will never be at the same terms. And that particular transaction that you try to alter is just invalid because all others do not have it. There are multiple blockchain types. There is Bitcoin, of course. Then there is Ethereum, which is a cross-industry collaborative, and I'm going to talk about Ethereum today. There is Ripple. Shubham talked about Ripple before. And then there are alternative blockchains, Steemit and Lazooms and Hyperledger and whatnot. Okay. There are 3 types of blockchain out there. There is public blockchain. Okay. Now stop thinking about Bitcoin for a while. Okay. Start thinking about having that ledger power with you. What can you do with that ledger power? Okay. It's not just about mining Bitcoins. You can use it in other things as well. So in public, you have many unknown participants. Writes are by all participants. Reads are by all participants. And the consensus is by proof of work. Okay. That is the mining that you're doing. In private, there are known participants from one organization. So if you are a bank and you want to implement your own blockchain for your own solutions, you can do that. Okay. You have right or restricted if you want. So you can have the entire banking system on blockchain itself. Okay. And it's going to be really cheap for you anyways. So if you know the banking sector, they spend a hell lot of money on security. They spend a hell lot of money on databases, right? And this is something which can actually just kill that business. Okay. But that doesn't mean Microsoft is not going to be there. So, yeah. that's why I'm here. Okay, so and the third thing is consortium, wherein known participants from multiple organizations can come together, which can be an example of insurance companies having a consortium. Okay, there are so many insurance companies, but they can have a consortium, they can all take part in one. Okay, so if you remember, the rights require consents of several participants, the read may be public or restricted, and there are multiple algorithms for consensus. Now, I'll tell you an example of consortium is that your car met with an accident with somebody. Okay. Now, the rule says that you two should actually share the insurance information with each other. Okay, and whoever agrees to will pay for the claim, actually, right from his own pocket. It's not your insurance provider who will charge you for that accident. This is how it should be done. In India, we do it with muscle power, but in other parts of the world, they are more civil. So in that case, what you can do is you can have a consortium of insurance provider, and they can run that workflow of providing claim from one party to another over the blockchain itself. Okay, and the information can be public in pieces where it's required to be public, and in the pieces where it's required to be an intercompany workflow, they can keep it in a private blockchain, right? So the endpoints they can decide. So how does it work? Company A wants to transfer a value to company B. That could be a digital currency, it could be a digital assets, this could be a certificate as well. Okay, if you know, the digital certificates can also be shared with the help of blockchain, and a lot of people are already doing that. Okay, a lot of digital certificate companies have already moved on to blockchain. Okay,
Like,
my customer, I can't name you. Sorry. Okay. Company A uses a digital app to transfer the value to company B. The app stamps the transaction with company A's digital signature, and now it needs to be verified by blockchain. Company A's transaction is stored in the ledger as a block with other transactions. The block has a unique ID, of course, the transaction time and the ID of the previous block in the chain. The block containing company A's transaction is then broadcast to the entire network to be verified in each node, and once it's verified by everyone, and for verification you pay, of course, right? After the verification process, the company B receives the value, and all the transaction history remains permanent and transparent, available for all the blockchain participants. But of course, the paying part is something which is not physical paying in the private blockchain scenarios, because they don't worry about the ether or the Bitcoin itself. They are more worried about the process. Okay, the process is safe. If it takes some ether, doesn't matter, because there is no physical value to the ether in that case. Okay. The evolution of blockchain 1.0, simple ledgers that record transaction. That is what blockchain 1.0 is. Okay, that is what you see right now. Now this is the traditional system, right? There is a centralized system with stored ledger, that is the bank, the one who holds your ledger, or maybe multiple banks who share. Actually, banks do not share a thing. Actually, they just give your transaction ID and say, "This is what I have done. I have sent money to that third party, who is trusted by his government." Okay, not entirely by me. So if you send money from here to the bank of Timbuktu, then your bank will say, "I have sent money to Bank of Timbuktu, okay, who is authorized by the government of Timbuktu, and you can expect the money is there." Okay. Now, if the Bank of Timbuktu goes defunct, that's not my problem anymore. Okay. So the blockchain actually is that you have this ledger in multiple locations. That's it. Okay. There is no third party involved. But the human beings, as messed up as we are in our head, we have got third parties here. Okay. This is a basic blockchain example. Alex wants to send Katie $500 via financial transaction blockchain system. You know, a transaction is created from Alex to Katie, amount 500, a digital signature is generated, and there is a timestamp as well. Transaction is confirmed through mining, okay, and then it's confirmed by all the nodes, and then the transaction is confirmed and it gets pushed to the network. Okay, this is how it happens. chain creates a transaction chain that maintains the history of ownership of an asset. Okay, so who owns is known. Okay, so it's not like it's completely anonymous. If it's anonymous, then how would you know who holds it? Okay, but the anonymity in the system comes from the fact that what you saw in that website when they were showing you the value, it showed you a big address, and address is nobody, basically. Okay, so the people who were trying to rig the system, they thought they can get away with it, but this is not how the world works. The agencies out there, they are more vigilant. They can go back to whoever implemented this entire system and crush them and ask them, tell me who did this transaction, find that person out, IP address and whatnot, and they will find you.
And yet they did not find
Yet they did not find Satoshi
Satoshi.
Nakamoto because Satoshi Nakamoto hasn't done anything wild as such.
He did not did any transactions.
He is probably a person, and he is probably an organization. He is probably a group of people who name themselves Satoshi Nakamoto, and I think it's good that it's like that. Okay.
Correct.
You don't want to find those people who actually did this revolution. Just like the fact, so Julian Assange is out there, and everybody knows that he owns WikiLeaks. It would have been better if nobody found it out, and WikiLeaks would have run better, and people would have trusted it more. But now that you have a person, you can say that person is probably aligned to that party, like that. Okay, so moving on, blockchain 2.0. Now, blockchain 2.0 contains smart contracts and logic tier. Smart contracts are unable to access external data or events based on time or market conditions. Okay. Coming back to smart contracts is that now, let's say that you want to bring some kind of contract between the systems. So you can say these are the three values that are going to move from here to here. These are the three values, and these are certain rules around this contract. Who can do what with the contract? What is going to be the workflow for that contract to complete? Okay. So a contract can actually drive you through a big workflow, wherein you can have state of the transaction with you, and everybody who works with that state can alter the state and say, now the state is this. Okay. So if I'm a insurance company and I'm supposed to process your claim, the first thing is, first party will submit. They'll submit their paper. Okay. The status state paper submitted. Okay. That's one transaction. Another transaction on top of that is paper reviewed. Okay. Third, paper in physical review. So anybody who's setting that state can only set one state. Okay, that's the way you are controlling it, and you have the full chain of transaction with you. Once the claim is processed and given, and it actually went off from your account, that means you have the full transaction workflow with you now. Okay, and it's all without any third party coming in the picture. Okay, everybody is doing it through the application just as they were doing, but now there is no one single database to hold that data, and you don't need to worry about the availability, the reliability, and all that stuff, right? So this is how a traditional contract looks. This is how a smart contract looks. It has logic, it has properties, and obviously it has your ledger. Okay, and it's all deployed to multiple nodes out there. Blockchain 2.0, more complex examples can also be there. I won't think I'll talk about this. I think I'll let the next speaker talk more about this. Okay, and then there is blockchain 3.0, which is coming. It has cloud servicing, multi-layer, middle layer, and triplets for organizations. So this is something which organizations are more interested in. It has more levels of control in the workflow. Okay, plus it has cloud service associated with it. So if you are a company and you want to deploy a 1,000-node blockchain for yourself, it's easy. So now you can go to Azure, you can say, make me a 1,000-node blockchain. Okay, and use these kind of machines to create that blockchain. Right. So if you want GPU machines, you can go for that too. I'm going to skip that. So what are the potential benefits of blockchain? I'm sure you understood this by now, is that it eliminates the intermediaries, reduces fraud, operation simplification is there, it helps you to reduce cost and time related to the reconciliation and disputes, and it helps increase revenue from new business model and savings, of course. this is where we are talking more in the concept of the financial services, is that from operational point of view, it reduces or eliminates the manual efforts required to perform reconciliation and resolve disputes. Regulatory efficiency improvement is there, near real-time monitoring of financial activity is there between the regulators and the regulated entities. The counterparty risk reduction is there, and need not talk about fraud minimization. It's just minimized at all levels because of the fact that the ledger is living in multiple machines and it's verified by everyone in the node. Now, a big business scenario, I have about 30 plus business scenarios, but I'll just talk some details over here. If you want, I can discuss a particular business scenario in more details for you. So, I'll just take a sip of water, maybe you'll just read through. I don't need to. So, healthcare can use it, remove third-party verifiers, such as health information exchanges by directly linking patient records to clinical and financial stakeholders. Now think about the fact that medical record companies do not survive because of the fact that one medical record company doesn't share the information with another medical record company while it's held by one person. So a lot of times the companies came up with their own medical record systems, right? Google came up with their own, which they shut it down. And I think Microsoft also has one. And then there are multiple medical record companies. So you get admitted to one hospital, okay, and then you get admitted to another hospital. The first hospital will only share the paperwork, okay. The digital records they will not share, okay, because the other hospital is maybe using some other, right? It is your information, and even if you want, you cannot share it, okay, because they are in two different systems, okay. What if this entire information can live in the blockchain itself, and you authorize it whenever you want to share it with somebody, and you can also put some time on that and say it's only available for X number of hours for you to consume, right? Now anybody can just go ahead and find it, from that hospital wherever you want to share it. This is one of the scenarios. Government, of course, it helps you increase transparency because that's what governments want. And track the asset registrations, reduce fraud and operational costs if you will. So there are plenty of cases out there. This is the blockchain disruption happening in financial and insurance world. You can see a lot of examples happening over here. Okay. The escrow services for real estates can also use this. This is a workflow for escrow services of property registries and the balance information. Is that buyer can send contract with the proposal, inspector inspects it, approves and notifies the seller, sign contract with the property, buyer's final approval, seller final approval. Done. Right. Now talking about Microsoft Azure Open Cloud, when we have everything in the open source that you can think of, okay, we don't need to talk about that. There is so let me talk about a little bit about the Bletchley project. Bletchley is a code name project inside Microsoft wherein we are trying to provide as many services around the blockchain world as possible to the world out there. So there is R3 Coda is available, which is a well accepted financial services blockchain thing. Then there is Enterprise Ethereum, Hyperledger is also supported. And this is the Bletchley framework, by the way. So the identity integration with the line of business, the privacy, the management, security in depth, operations and management, all things are taken care of in this. So if you are an enterprise who wants to use blockchain, and let's say that you want to do authorization of your transactions using AD, right? You can do that. Okay, because as an enterprise, you still want your basic line of businesses to work with this system, right? So you can trust it and it works with you. So from the blockchain point of view, Microsoft provides an Ethereum consortium blockchain as a service. So you can go to the Azure portal and make one. I'll show you how to make one. And then others are provided as virtual machines. You can go ahead and host your own virtual machine, create your own cluster of either one of these blockchain out there. Okay, this is one blockchain architecture, but which could be really difficult for you to understand right now. Tenets of our blockchain as a service strategy is that you can do fail fast and cheap with having a development and test environment readily available for you. Okay, you don't need to actually go ahead, buy hardware and then do the testing, if you will. You can do a mix and match from the world-class blockchain technologies, and there is no Microsoft proprietary thing going on with either one of these platforms. It's as it is in the open source world. You can create and innovate by building solutions on blockchain very quickly, and you can share your solutions through a worldwide distributed platform, that is the Azure Marketplace. And you can provision with one click, test it and iterate it as quickly as you want. So I'll show you a small demo of Azure Blockchain service. So how do you make blockchain on Azure is really simple. So you go say new, and you say Ethereum. This is a Azure Marketplace where you can buy all of the Azure services. And here I can pick Ethereum Consortium blockchain. I can also pick an Ethereum Consortium leader. And these are Microsoft images, by the way. Okay, on the open source stuff, these are Microsoft images. And then there are plenty of other blockchain images as well. There's a truffle image as well. If you know, truffle is used for unit testing of your blockchains out there, but I think we'll pick Ethereum Consortium blockchain for now. And obviously, although it is a service, but it is backed by VMs. Okay, so you provide a resource prefix. Let's say provide EEX2. This is the username of the machine, and then you provide a password. And you provide a resource group which will hold all of these machines and infrastructure that you are going to create. I'll say EDX.ERG4. I can select the location where it's going to be deployed. Okay, plenty of locations for me to choose from. Chosen West US for now. And then you decide on the size of your network as to what you want. Okay. Now this particular blockchain that I'm making is going to have a public endpoint, but you can make it private endpoint. Okay, because it's based on virtual network, you can actually make it private, and you can make it work with your existing line of business applications, if you will. How many members of consortium are going to be there? You can select. Okay, the number of mining nodes you can select, and then you can also select what kind of replication is going to be there. Are they going to be locally redundant or geo-redundant or read access geo-redundant? These are the strategies by Microsoft to make it highly reliable and available. So, you know, I think one of our speakers was talking about the fact that machines can go down, and whenever they come back they have to start working. It's because machines do go down, and you actually end up buying that hardware because you have to buy that hardware before you actually test how mining works. But if you are me, you would not go ahead and invest in that on day one. You would probably like to do it yourself. Azure is probably the best place to go ahead and try that out. Okay, if it works at all. And these are ready images, you don't need to install anything. They come pre-installed with everything. Okay, and you can set up the geo-redundancy and everything. If anything happens to the machine in one particular data center, the other data center takes care of it. Okay, transaction nodes. You can decide if you want. You can go ahead and talk to Azure support to increase the number of nodes. Okay, and they will help you do that. The mining nodes type, there are plenty of machine sizes available over here. So if I do view all, I'll be able to see some really heavy duty machines as well. Okay, I think this is D series and A1 series. N series is probably the best from the GPU point of view. So I don't see it right now because mine is an internal account and I'm not supposed to spend that kind of money. But yeah, you can go ahead and select those as well. And once you are done with that, you do some Ethereum setting. Okay, you provide the network ID and the password, so you can access it, and then it will show you a summary wherein you will actually go ahead, read it, and click on a button, purchase, and bang, it's done for you. And once it's done for you, if you go to dashboard, you'll find that it's already there. This is your number of resources that it has developed for you. Okay. So I've kept it ready. Otherwise, it usually takes 5-10 minutes to deploy these resources for you. Okay. So if you go there, there's a public IP on which you're going to talk with your blockchain. Okay. So if you click on that public IP, and this public IP is already here. Okay, copy that public IP and do SSH to this public IP on port 3000. You can change the port as well. Okay, from security point of view, we've kept it 3000 because a lot of people find hits on port 22. Okay, this is a normal practice. If somebody finds a port, they will probably start hitting the port 22. That's a general thing they do. But you can change the port over here. Okay, and then you can directly SSH to it, which I've done in this particular case. Let me see if I can increase the font over here. Okay, cool. Is it readable? Okay. So the first thing is that this it has the Ethereum for you, okay, and I just did a command called detach, and I've attached myself to the Ethereum process in the system, and then I can see what are the accounts available, so, and what is the value that my accounts have. So if I want to just know if I have a particular account, the account 0 is something, it's a basic account that you will get with every one of these nodes. You do ETH.account 0. This is a similar kind of address that you saw in that demo over there that Shubham was showing, right? This is similar kind of address. There is another account over here that I created, and it also has another address to it. Okay. Now, if you want to, you can also find out the value of a particular account. So I can say ETH.get balance, and then you provide for which account do you want to get the balance. Okay. This is the balance of the account 0, and I did a transaction, so I must find the balance of the account 1 as well. This is the balance of the account 1. Okay. So now, if I want, I can send money or send the value from one account to another. Okay, which is pretty much like this call that we did over here. Is that ETH.send transaction from account 0 to account 1, and the value is 1 Ether. Okay, in Ethereum, the Bitcoin equivalent keyword is Ether. Okay, so did anybody thought that there are so many currencies? Okay, we all are excited about mining those currencies, but is anybody buying and selling in those currencies? That question comes to your mind, doesn't it? So try to do some research around that, and you will find that most of these currencies, although being mined, there are very few people doing transactions in the real world with those currencies, right? Purely because we have trust issues. Okay, humans have trust issues, and although it's technically guaranteed that the currency is safe, we still want somebody else, a third party, a government, a bank, to come and tell us that it's safe. Okay, and if anything goes wrong, I'm there. Okay, that's what your banks do, right? If anything goes wrong, that's what your governments do. They keep a trail of everything, but if everything goes wrong, you can go and say, sir, this guy took money and didn't give me the papers. Okay, we had a contract. So it's very much well taken care of. This is the reason why I can go to Supreme Court and say this builder is not giving me my house. Okay, we had a contract, right? But if you would have done the similar transaction in blockchain 1.0, there is nothing you could do about it, right? the physical thing that you are buying. If you don't get it, then what can you do about it? Okay. But then the smart contracts came, which were like, okay, the money will only be released if this happens. Okay. So that is there. So we can. Okay. Now I have to unlock the account from where I want to send the money. Okay. So I will have to unlock account. So I'll say ETH unlock account, okay, and then provide ETH dot get account, or get accounts, sorry, ETH dot account 0 and something like this, okay. I don't remember all the commands, so if it doesn't work, we have to see. Oops, it is a function. Yeah, this is the, which is what I wrote, right? Oh, sorry, personal dot unlock account. Sorry. So do personal dot unlock account, and the account is unlocked for you, and then you do the send transaction. Okay, from 0 to 1. If you have enough ether to send, okay. And I think we had, so now we can do ETH.get balance, and we can see this guy has 2 now. Okay, he had 1 before, he had 2 now. So this is the Ethereum blockchain. Okay, now another thing is to have contracts with this thing. Okay, now for contracts you can actually do those on Ethereum, but I have done a little bit of testing with the help of Truffle. Now Truffle is a tool out there which can actually, Truffle and Test RPC is a tool out there which helps you emulate the transactions, and actually you can go ahead and deploy your contracts as well and see if they work or not. Okay, rather than actually going full blown on the entire blockchain, you can actually have just one machine and can claim it and see if it's working or not. So I have a contract here with me. Okay, this is my first contract, which is a storage contract. Okay. You can see it uses a framework called Solidity. Solidity is a JavaScript-like language out there to write contracts with. Okay, and just like any other contract, this is a very mundane contract, by the way. There are 2 functions over here, one which returns you a value and another which sets a value. Okay, it's pretty dumb out there. Now there is a parent contract as well, which uses this child contract storage.sol. Okay, and this is how you just should name your file .sol. Okay, and I must tell you, the compiler of Truffle is an ass. The errors that it will give you, you will probably not be able to understand. Okay, so be extremely careful with your semicolons and lines and everything. So for example, this should not work. Import storage.sol will not work. It better be /. But if I run this over there in the cloud, it will give me an error like C not find, something like that. Okay, so just have to be really careful about this. So what this does is actually it creates a new storage. Okay, sets a value. That's it. Okay, and what we will do is we will have 2 windows, in which one where we are actually going to compile our contract, and it is actually just going to create a storage account, set a value, and on the other side it will show us that it's working or not. Okay, so I have 2 windows open over here. Now for that also I have created one VM. Okay, this is my VM, which is a Linux VM right now. Okay, and this Linux VM is running Truffle and Test RPC both. Okay, and it's available on a public port, so I can SSH to it. Okay, so I'll just go over here, and this is my Truffle admin. Okay, I've done some transactions before, but I'm just going to rewrite that. So here I am. I have to do is just go to this machine and say Truffle init. When you say Truffle init, it will generate a folder structure for you. Okay, and you will actually go ahead and copy paste your contracts over here to run. So that is what we have done. Our contracts are here. So if you go to CD contracts, or sorry, I'll just BI them here. Just increase some font size for you guys. Okay. Right. So I'll increase the font size over here as well. Okay. So the contracts are there in the folder. So I can say CD contracts. Sorry. And our contracts are here. Okay. There's a contract of parent. There's a contract of storage over here. If I go ahead and do a vi storage.sol, you can see it's the same contract. Okay. And then there is a vi parent.sol, which is just the same. Okay. You author this file, the .sol file. Okay, on your machine.
If I don't know what exactly I'm talking about with file,
Yeah, go ahead.
I simply cannot understand what I just said. Maybe because I'm not from a technical background.
Oh, go ahead. Go ahead.
But
Ask
like,
me.
what exactly you've been doing? You said
So-
that you're using Truffle to verify.
I'm just
You're
using
sending
Truffle to
it
test a contract.
Yeah, you're just using.
Right. But why a contract is a bigger question. Okay. Generally, what you see in blockchain world happening is that you have some bitcoins that are moving from one place to another. Right.
Actually, I understand the aspect about why a contract.
Okay.
How a contract works.
So how a contract is similarly that you need some kind of programming language to author a contract. In this case, Solidity is a programming language that is helping you author a contract. Okay. Maybe in future you will start seeing some easier tool to author a contract. Like in the real world as well, if you are an application developer, you know that you still have contracts between the service-oriented architecture world, right? How many of you know about service-oriented architecture by the way? One hand, two hands, three hands, that's it. How many of you are application developers? Come on, just raise your hand. You never, and the rest have never developed an application, is that so? Raise your hand if you've never developed an application. That's still a good number. And those who haven't raised their hand in either of the things, I don't know what they are.
Trying to develop an app.
Or maybe a free coffee. Anyways, so the thing is that when you are working as two different entities, if I'm an enterprise and you are some customer who is trying to use my API or any services that I provide, I need to provide a certain contract, and I need to say that this is the contract that you have to follow to share information with you, right? Okay. If the information is not in this format, I'm not going to accept it. Okay, this is my contract. Okay, this is one example of having a contract. Okay. A contract is also a digital contract between two parties as well. Okay. So you can say that meanwhile we are processing this claim, accepting information from you, this contract states that we have to go through three processes. Okay. And those processes will be defined in this sol file, in this Solidity file. Okay. After that, when the transaction will move forward from point A to point B to point C to point D, they all have to follow this contract. Okay. And that is the only thing they can do. Okay. So like our contract says that you can only set an integer. Okay. Then you cannot set anything else. Okay. If you bring in any other kind of value, it will say sorry, cannot work. Just like that. Okay. So this is the basic of it, of a contract actually, is that you are defining a set of rules to follow in a transaction. That's it. Okay. Now how is pretty much like you just go ahead, author a file, upload it, and that's it. From that point onwards, you can also define in your file who gets to do what.
So I'll always need a technical person around me.
You will. And that's why the people who raise their hands are very vital to you.
How many people use
So that
Solidity?
How many people?
Like what is the penetration of Solidity in software?
So much I've heard, I have heard, I think this is the most popular out there. Everybody is talking about it.
So not just specific to blockchain, otherwise.
I don't know.
This is for blockchain.
This is for blockchain.
Can you ask the same question again? How many people are actually application developers? I
Okay.
want to know.
How many people are application developers out here? Raise your hands if you can. Please. Okay. Do you know some guys then? Okay.
No, Bangalore.
Okay. Cool. So this is how we have done, and then what we did was we ran a command called truffle compile. So this is actually going to, and then I'm going to say truffle micro. Oops, the rendering didn't happen the way I wanted it to render. Yeah, but this is what happened. 840, 840. This guy is not rendering it well for me. But yeah, so a contract got created, some gas got used, the ether itself, the block number was provided, and it basically shows a transaction happened for me. Okay. One can debug this further as well if they want to, and I don't know how to, but there is a process for that. So I just need to let you know that it can be debugged. Okay. So this is the basic of having a transaction out there and having a smart contract. I think the next speaker is going to talk more about how to implement smart contracts in the real world. Okay. And today when we were in the huddle, we were talking about this fact only, that there are a lot of application developers out there, but they are not upskilled on blockchain, so to say. Okay. And this is not unlike any other language out there. This is not so easy to upskill, right? So it's better to have some workshops where we can all come together, do a workshop, learn more about blockchain. Whatever I've showed you is not proprietary, so to say. This is all open source, this is all out there. It's not something we have written. We just created a small orchestration, a service around it, okay? And then so that it could be used by enterprises. That is the only reason of having that blockchain as a service out there, okay? So if we have many developers doing this, I think it will be a win-win for,